Okay, supposed to draw the region bounded by the curves. We got y equals 5 minus x. It's got a y-intercept of 5, and it's negative x, so it's decreasing 1 unit for y for every 1 increase in x. Slope of -1, right? Y equals x, that's a slope of +1, starts at 0. And then they set at x equals 0, so that's this line right here. Those 3 red lines intersect right here. So we're supposed to take that region and revolve it around the y-axis, so it's going this way. Okay, man, I know I've done this before. Okay, so I looked, I don't have enough video for this. So we're revolving this around the y-axis. So there's an infinitesimally small right cylinder. No height, I mean, the height is approaching 0. So what we need to know is the radius of each of those disks. And the radius is going to change, actually it's a triangle either way. Can we do anything with that? I mean, it's a perfect triangle because these slopes are perpendicular, right? So one trick we have up our sleeve is that cross probably at 2.5, right? So if they cross at 2.5, we can set up our integral to integrate from y equals 0 to 2.5, and we can just double it, because whatever that volume is halfway through, it's going to be the same volume going back up. And you could confirm that by plugging in x in here, solving that equation. You can get x equals 2.5. So we'll use that symmetry to our advantage. That way we don't have to set up 2 separate integrals. And then we need to know the radius, and the radius is dictated for this bottom half by y equals x, right? So the radius is the distance from here to here on the x-axis is always equal to y. So that's our radius. We need to square it, and it's pi r squared h for the volume of a cylinder, and h is infinitesimally small. Magic of calculus there. Okay, so now we can do the antiderivative. It's pi y to the third over 3 from 0 to 2.5. And then if we plug in 2.5, actually it doesn't usually like decimals. So let's change this from 2.5 to 5 halves. Right, so if we plug that in, pi 5 to the third power is 125, 2 to the third power is 8, that's all over 3. So instead of putting it all over 3, we can say this is divided by 3. And if you're dividing by 3, that's the same thing as flipping and multiplying by 1/3. I'm trying to keep it as one fraction instead of fractions on top of fractions. So we got pi, and then 8, 16, 20. This is 24 for 125. Multiply that by 2, so that gives us 12 on bottom. So I got 125 pi over 12.